we're going to talk about Hamilton paths and Hamilton circuits. So if we look here, when we were talking about Euler, we cared about every line, every vertex, every edge, all of that. But Hamilton's different. Hamilton said if you have a circuit, you will start and end at the same place. So this would be an example of a circuit. I can start like at A. I'm going to go to B, go to C, go to D, go to E, go to F, and then I could make my way back to A. Notice that I did not care about these lines. I only want to go to every single vertex. That's the big difference between Euler and Hamilton. We are only focused on the vertex. Now, did I have to start at A? No. Let's start at F. And then I'm going to go to E, D, C, B, A, then back to F. We will just need to write out what we did. So F, then I went to E, D, C, B, A, and ended back at F. Now, the important thing to note is that I could not go like here and then go back to B, or you cannot return to a point. So with that being said, we will look here. And if I tried to make a graph and I wanted to go E to D to A, B, C, I would need to go back to D so I can get every vertex. But that's not a thing. You cannot with Hamilton path. If we were talking Euler, cool, that's great. But Hamilton cannot do that with a circuit or a path. So because of this placement of the vertex D, this is not possible. Because again, you cannot go to a vertex more than once. So we understand Hamilton circuit, where you start at one point, are able to go to all the vertexes and end at that same vertex that you started with. Now we're going to talk about Hamilton's path, is where you start and end at two different vertexes. If I start here at A, I can go to B, C, D, E. Now, if I wanted to try to go back to A, I would have to go here to B again, and that's not a thing. Remember, we cannot go back to vertexes that we've already went to. So I'm going to have to end here at E, which means my starting point, which is A, then I went to B, C, D, and E. So I did not go back to A. Could I have done this a different way? Yes. I could have started at E and gone backwards. That's also fine. Just understand A, because it's alone out here by itself, and B connects to both E and C, A needs to either be your starting point or your ending point for this one. So we'll go ahead and keep it in alphabetical order. Now we can also have them like this. It can curve and go around. You will just have to start wherever you want and see if it's a path. And if I continued here, I would have to go to A, which would not lead me back to E. So it's not a circuit, it's a path. The path in which we took was E, D, A, B, C, and F. So that is how we can determine. Let's look and do this one right here. Can we cross lines? Yes. But did that work? No. But the thing is, I know this is a circuit. So let's just go ahead and do that again. So sometimes you see we will have to do it more than once and check. Don't just trust your first instinct and go with that. So I went from A to E to D, to C to B to D, then back to A. I want you to notice that when I'm writing this E should have been pink. I want the starting letters to be different colors because we need to be able to go back if it's a circuit. Now, what I'm going to tell you cannot have is if I had an A, B, C, A, E, that is nothing. If I stick an A at the end, it's nothing because you cannot have another number or letter, you cannot have one in the middle like this. That's been repeated. If this was another C, that is not okay. You can only have it repeat at the beginning and the end for it to be a circuit.